As usual, we start out with this first slide that's just talking a little bit about DesignX and what this product does. And I just try to give the summary in slightly different ways for people that have heard this over and over again. I'm sorry, but I just want to make sure that everybody understands what this product is and what its intended use is. So, as I always propose this, there over the many years, 30 plus years, devices similar to one screenshotted here on the left-hand side came about on the market, capturing 3D measurement data. And many of them capture highly high resolution and in some cases high accuracy uh, data, 3D point cloud information or polygon information that is very high density. And when those devices came about in the market, immediately engineers and designers and people within quality departments saw the possibilities there that these devices could be used to capture the shapes of parts and bring them into 3D softwares to either make comparisons and measurements or reverse engineer the shapes of parts. There became quickly people noticed that that data was too dense and of a different nature than most of the 3D CAD softwares that existed in the market. So specialized softwares cropped up to deal with that. And DesignX is our solution where we take these resolution, very high density scan data sets, and we allow you to work with them in a native environment and recreate CAD models or other deliverables from that data for use primarily in manufacturing, but not only limited to manufacturing, and lots of other markets as you see on the right-hand side, whether it's CAD, CNC softwares, and just going straight to manufacturing. And as you can see, the additive market where printing and those types of deliverables are also captured. So DesignX, its specialty is taking that scan data not as a second class citizen into the CAD world, being able to extract whatever it is that you need out of that information to then send downstream in your manufacturing workflow. And our webinar weekly focuses on different applications similar to this one that's shown right here, where these impellers are reverse engineered to recreate these highly organic shapes into CAD models, is highlighting different applications similar to these that are success stories for DesignX. And along the way, I give tech information or tech tips for current users of the software. So this has multiple layers to it where we talk about successful applications where we've utilized the software, and we try to sharpen everybody's skills by highlighting specific applications that are very interesting. So before we jump into our applications in our presentation today, as usual, I wanted to go over our Geomagic DesignX product tiers just to make sure everyone is aware that today I'm using Geomagic Design X Pro, but we also have two other products within this product family. So we have the ability to sell Geomagic Design X Go, Geomagic Design X Plus, and Pro. So I just wanted to make sure that everybody is aware of those. I like to say that Go is designed around extraction. It doesn't have plugins, and it's designed around extraction of primitive shape sketches and all of those things. You can do advanced modeling in there, but I would say it's good at extracting and sending that stuff over to CAD. And remember, it doesn't have plugins built in. It will import scan data from almost every source imaginable. And then plus is those same import tools, but we also have the plugins built in. And outside of that, we also have more modeling tools. So it's the basic modeling tools as opposed to DesignX Go. I like to say it's more about extraction and sending over to CAD. This one you can do basic modeling or also send it to CAD, as all three of these have live transfer built in. And then, of course, Pro, the one that we've talked about extensively on this webinar series. And we do have subscription options available for all three tiers. So with that, we'll go ahead and jump into today's content. For today's application, the market vertical is within the industrial products range. And before we jump into the actual application, we'll switch over to the scanners. For this specific application, it was a white light type scanner like this one or this one, a structured white light scanner, kind of like these right here that are on here. So those that don't understand or know, those types of scanners have a projector that projects a highly accurate pattern on the part, and it looks at that pattern and from a different perspective with another camera that can then see the change or the shift and calculate and triangulate per pixel the distance measurement. And then a lot of them also tie in with turntables and things like that, so they can utilize those turntables to turn the part around. And historically, these devices are highly accurate, high resolution type scanners that do a great job capturing objects, especially smaller objects. Yes, there are larger ones by using targets and things like that. But yeah, that's the kind of scanner that we used for this application. So this one is a Helix application, and there are lots of industrial products that utilize Helix within their design process, and I break this out as a separate application because working with Helix in CAD can be a very specific specialty, right? Within the CAD modeling world, you can reverse engineer square blocks and things like that, a very simplistic geometry. But Helix is, especially reverse engineering a Helix, can be a little bit challenging. And I will address more Helix approaches that we have attacked with our software in webinars to come. But today we're going to start out with a basic one, and I feel like we'll just build upon these Helix applications and show some more elaborate examples and a variety of different types of approaches as well that were novel that we used our software for. So as you can see here on the left, there are lots of helical type parts, not just bits like this. There are augers and all kinds of different things that utilize this type of geometry. And the general information that we need to gather is the profile that was used to sweep about the helix, and then some key dimensions, which we'll cover when we're inside of DesignX. And once you have those, then you can create a helix and then sweep and cut it away and create the geometry. And it becomes a little more simple after that. But those initial stages of dimensioning and creating and finding out what that helix is really where the challenge lies. So for today, we'll go ahead and jump in using this application and jump over to DesignX and start rolling back a history tree and taking a look at how we approach this part. So here is today's model. Just rotate it around here. Really neat. It's not a super basic one, because a super basic one would have a little more simple profile to it. So it has a little bit of a advanced aspect to it, and it's got some ramps in and out of it that aren't consistent with the overall profile as well. So that makes it a little bit special. If I go ahead and turn off the CAD and turn the scan on, you see here's the scan. So you see the profile is a little bit different, and again it has these ramps that are different on the in and the outside. So we'll go ahead and roll back here and walk through this history tree here. So there's the scan. We'll go ahead and march forward. It looks like we calculated, obviously, we calculated a center line and we drew a sketch here. And this is just the overall stock sketch. So if you pretend like we're going to make this on a lathe, we went ahead and created a profile and drew out the sketch and created the solid stock here. So it go ahead and roll forward, and we revolve that and created that overall stock, and you can see how accurate that is. I don't always highlight the deviation, but let's go ahead and bring that up right now, just to check your accuracy of your reverse engineering, just to see how closely you follow the mesh. And again, following the mesh closely is your decision, whether or not you need to or want to, and the application specific, whether or not you're trying to follow the scan data accurately or closely or not, because that scan may have deviation in it that you don't want to capture in your model as well. So we do have that deviation, and you see as I roll over the surface, you can see that I can see exactly how close, it's like a feeler gauge in each individual spot that it is. So I sometimes overlook that tool, which is a massive benefit to reverse engineering in here, because at any moment in any tool, even in the middle of using tools, I can turn on the deviation and see whatever I'm working with, whether it's a sketch or a surface or a solid or whatever, how far it deviates from the original scan. So yes, sometimes we overlook some basic things, but I wanted to make sure that I bring it up again to make sure everyone understands. So with that, we'll go ahead and get started on the extraction here. Now, this first sketch may seem very simple here, but this is critical to the Helix application. So when you see a Helix, the first thing to actually understand, the number one thing you need to figure out with any Helix is how many starts does it have? So how many threads does it have? And some people may ask, what are you talking about? If you've never modeled a Helix, you need to know. So you see here, because we haven't modeled yet, you see here, there is a cavity that needs to be cut here. And if I rotate it around, there's also a cavity over here. So this one, and if I roll around, it has two starts. Not every single Helix has two starts. Like a threaded bolt, actually, for the majority of them, only have one start, right? So it's one cut that I'm going to spiral around the outside, and that thread will thread into a threaded hole, right? It doesn't have to only have one start. There are examples out there where people can use multiple threaded multi-start, and I can't think of any right off the top of my head, but that is a possibility, right? Now, with augers and stuff, many times there are multiple starts or fins, right? Is another way to describe it based on an auger's terminology here. Or with this drill bit, it's two different galleys that will remove the material and throw it up and away from where the cutting surface is, right? So that is the number one thing, is how many starts does it have? And that factors in with this second piece of information that we need is we in this instance what we do is we go ahead and you'll see that this person modeled the profile as it intersects with the scan data. And the reason why we did that is to understand where a point is or where a zero is. You can do it, you can measure however you want, but you're really just measuring what is the distance from center to center of these, so you know what the pitch is, right? That's essentially in the thread world what the pitch is. So what is this dimension right here? We're using this sketch not for reverse engineering as far as creating the model. We're using this for measurement to understand what the distance is from here to here. And the reason why I started with you need to know how many starts there are is if there are multiple starts, you have to skip this one and measure over here, obviously, right? So once you understand the pitch here, and we also need some other pieces of information, which you'll see within the Helix tool in a second. We also need to know the diameter of the shaft, and then how many revolutions we're going to go down the thing, down the surface. But this is why we're creating this measurement here, is to understand mainly this piece of information and the diameter. And you can also create this reference geometry to reference in the Helix sketch later, which you'll see here in a second. So we'll go ahead and exit out of here and keep on moving to the next feature in the tree. So let's step forward to the Helix. So roll forward and turn it on. And you see when it creates a helix using the Helix tool, it creates it as a 3D sketch. And you see here that we're able to create that from the scan data, and it lines right up. If we go edit the helix, you'll see that there's this very interesting interface here. The things that we need to know to plug in to create this helix are, number one, the axis. So we select the axis. Two, the start point. So you see here, if we roll over here, this is the start point. So that same intersection of the sketch that we used to measure out and create our dimension is also going to be utilized to create a start point for the helix. And you're able to extend the helix in a backwards reverse direction as well, as you can see. So we started from here and we went that way, and then we said go in reverse as well. Now, where we controlled that, you come in and you select the axis, you select the start point, and then the way I operate is I come down here and you can click on these values here. So the height, so zoom out here. So if I change the height value and just make it like 400, you see that we go 400 millimeters from that start point right there. And you see the rotations are still the same, but we just went 400. And you see I can zoom on this timeline, by the way, down here. And then the radius is captured when I click on that point, although you could override and change it in here. And then the pitch is that 110 millimeters between here and there. So if I change the pitch here to like 200, you'll see that there we go, we messed it up. So 110, and there you go. And if we shorten it up 50, you'll see there. And then you can adjust how many revolutions here. Let's do like, so you can adjust it based on how many revolves as well, which that then changes your values here. So you're seeing that I can drive it based on the pitch or by the revolutions if I need to. Obviously, when we're doing something along this line here, most of the time I feel like we're dimensioning it based on the pitch itself versus how many revisions. And then so you see down here, you can also adjust it from there, extend in the opposite direction, and I could say 3 if I needed to, or 2. I can adjust the opposite direction revolutions, or come back to the 0.5 or whatever. So that's where you're going to adjust the opposite direction revolutions, this right here. So just to review, because this tool is very interesting, right? And most of the time when you're using the software, this type of interface is not used. This paradigm of having this graph down here. So you select your central axis, your start point. You can adjust counterclockwise, counterclockwise, extend in opposite direction, how many revolutions. And then in the initial dialog box, which it's not showing, you can plug some of this information in. But then if you need to change it, this is the thing that I'm pointing out here. This is not always intuitive to people. To click on these values down here in this graph to adjust that helix. Now I'm just going to escape out of this and not capture my changes, just in case I messed it up. So there we have this beautiful helix that's created as a 3D sketch, and it acts like a 3D sketch. So now we're going to roll forward, and you see that we created a plane, and we were like, wait, what's going on? What is that plane? If I edit the plane, you can see in division. So you can create a plane using end division. It's not necessarily the most obvious name for us here. So if I click on it and I say end division, what it'll do is it'll take whatever component that you select and see where it says all those different inputs. Most of the time, this is on curves, sketches, whether it's 2D or 3D curves. And I can say I want to create planes, end division. So I want 13 planes from the beginning to end, equally spaced out, uniform, right? Or I could say offset those 13 planes 1 millimeter at a time or 5 millimeters at a time along that curve, normal to that curve, right? So that's what they did here. I just wanted to point this out. This is something that I use, and it's awesome to be able to put a plane normal to a curve using this end division command, which is really nice. So you see they created that plane, and then they created another one here. End division, it looks like they created it. Let's just double check it. End division edge offset. So they created both of those. Just turn our planes on. Right there. All right, so now we'll jump forward. And we use that second plane, created a sketch normal to right here. And we turn off the mesh. And there it is. We drew a profile through that information and dimensioned it out. There we go. So now, just want to double check something here. Perfect. So there it is. We'll get out of it, and we'll take a step forward here. And we'll take a step forward, and there we have, turn this on, and turn this on, turn everything on. We have our sweep. And we'll go ahead and hide the solid. Really awesome sweep through the entire thing. So now that we have that created, that's the heavy lifting. That's the most difficult portion, is just getting that created. Now we can jump forward and see what we have next. They did another sketch here. We'll just see where they go with that. All right, so now we're going to create that off-ramp here. Basically identifying where this changes from the sweep to an extruded direction. And then let's see here. Offset these planes to then trim back in both directions. There we go. And then do a surface loft between. And sew those together, and now you see here we're basically just mapping over the separate profiles here. And then we're going to do fill faces on all of those. So now we have a beautiful surface there. Now let's go. I think we just go down to the other side here. Yep. On the other side, it looks like they did a sweep exit. We'll just turn on the mesh so we can kind of see. Instead of doing an extrude exit, they did a sweep along a profile. They drew that sketch down here that had a slight arc to it. So then I swept this profile along that. And then let's come over here. A trim back in both directions. And then they do the same thing here where we loft, so fill. And then from there, it will be blended. You see here, sometimes this happens where it does the normals in a different direction. Sometimes it does not matter. You can just sew it together. You notice they didn't do a flip normal and then sew. It's fine. So when they sewed it together, it matched the normals to the entire surface. And then instead of mirroring, they did a circular pattern to the other side. So just turn on this. You could mirror. Depends on where the start is and all that, but yeah. And then you can also circular pattern. In this instance, you can do that. So from there, we're going to do a revolve cut. So it looks like they jump away from this. And let's just come in here. Yeah, right down here at the end, they just cut out that notch. There for the lathe. They do a chamfer. Then they cut those away. Then they do the big cut. And then they roll to the end. Now we'll zoom out here, rotate around, take a look at that, and then turn on deviation. Looks really good to me. So with that, we'll go ahead and jump back over to our PowerPoint. I hope everyone has been enjoying the RE Lab webinar. And I'm always striving to make it better and gather input from a variety of sources. And I had the idea to create a survey and put out a survey just asking for feedback. Mainly the feedback is just to gather data points on the topics, the applications, and if there are any other ideas of applications that people might like us to focus on, and just kind of get the pulse of what you guys like to see, what you like to hear. So this is a very open forum. It asks for some feedback and suggestions, and we'll go through those and implement those. So if you have any proposed topics or things that you might want to learn about DesignX, then go ahead and scan this QR code. It takes you straight to a form, and we will take that and implement it. As I stated before, Geomagic Design X Pro is part of a complete lineup of software that has 3 tiers of Go, Plus, and Pro. And again, the differentiators are that Pro has all the tools built in, Plus has plugins and basic modeling tools, and Go primarily is focused on importing data. It has no plugins built in, but it brings in data from POI, OBJ, STL, all those different import formats. We have a huge library of formats that we bring in, more than almost anybody out in the market, and allows you to extract basic model information, send it over to CAD. So Go, extract basic model information, plus add plugins, add more modeling tools. Pro, you get everything. And you have the ability to upgrade from one to the other by trading in Go, trading in Plus to get Pro. So it's a great ecosystem, a great product lineup. But we wanted to make sure that we point out that Pro is part of this lineup and there are other options available.